Hello. So today we are going to learn about a very important concept for 8th class student. Not only for 8th class students, it is also important for 9th class students also. So the concept is square and square root. This is very interesting and very important concept in maths. And for 8th class, it is one chapter also is there, but the chapter name is square and square roots and cubes and cube roots. In the next class, we will discuss about the cubes and cube roots. But in this class, we require to discuss about the square and square root. First, we require to know what is square and what is square root. So, for example, if I take 5 square is equal to 25. 5 square is nothing but the product of 5 into 5. So, that is equal to 25. So, this we can call it as 5 square. The value of the 5 square is 25. And the root of 25, that means square root of 25, we require to take this pair of two factors, we require to write one value, that is 5. So whatever it may be, square root of 25, we can write plus or minus 5 also, but we are now, in this class, we are taking as a positive values of the square roots. So the square root of 25 is 5 and square of 5 is 25. So this concept is very, very important. What is square means a square is equal to a into a. So a square value is a into a, and the square root of a square is equal to, from this pair of two equal factors, you require to write one value, that is a. Square root of a is equal to a. So this is brief introduction about the square and the square root. But in this concept, here we are going to discuss 3-4 important concepts, that is how to find a number is a perfect square number, how to find a number is a perfect square number, how to find the square value, and how to find the square root value. These are the 3 concepts we require to discuss in this class. So by seeing a number, how can we say this is a perfect square, and how can we decide whether it is not a perfect square, and how to find the square root of the given number, and how to find the square of the given number. These are the 3 important concepts. So first concept is the properties of a square number, the properties of a perfect square number. So let us you take 1 square is equal to 1, 2 square is equal to 4, 3 square is equal to 9, and 4 square is equal to 16, and 5 square is equal to 25. These are some values of the perfect square numbers. I mean 1, 4, 9, 16, 25 are the perfect square numbers, because 1 we can write it as a 1 square, 4 we can write it as a 2 square, and 9 we can write it as a 3 square. So 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, these are all the perfect square numbers. So here my property number 1 is, the first property is perfect square number ends with 1, 4, 5, 1, 4, 5, 9, even number of zeros. Even number of zeros. This is very interesting property. Every perfect square, it will ends with, ends with means its unit digit will be 1, 4, 5, 9, even number of zeros. Even number of zeros means, for example, if you take 2500, with the ending with 2 zeros, therefore the number of zeros is even number, and it may be a perfect square, and it is a perfect square, that is 50 square. This is a 50 square. If number of zeros are odd, for example, if I take 250, it is not at all a perfect square, because number of zeros at the end is odd, because 1 is the odd number, so 250 is not at all a perfect square. So here I want to explain this property perfectly. So here my first property is the perfect square number ends with 1, 4, 5, 9 and even number of zeros. It does not mean every number which is ends with 4, 5, 9, 1 and even number of zeros is always a perfect square. Does not mean like that. For example, 81 is a perfect square. 81 is equal to 9 square. So 81 is a perfect square number, but 31, it is also ending with 1. So unit digit is 1, means it is not at all a perfect square. So here my property is, if it is a perfect square number, those perfect square numbers always ends with 1 comma 4 comma 5 comma 9 and even number of zeros. For example, if a number is ending with 4, so we can say it may be a perfect square. So you require to find whether it is a perfect square or not. If a number ends with 5, so you want to check whether it is a perfect square or not. If it's ending with a 9, it may be a perfect square. If a number is ending with 2 zeros or 4 zeros or 6 zeros, then it is a choice, it is a perfect square. So this property you want to understand like this. Otherwise, all numbers which are ending with these digits are perfect square means it is not at all correct. So perfect square numbers always ends with these digits. This is the first property. But the second property is very, very important. We can decide which are not perfect square numbers, which are not perfect square numbers. Here you see perfect square numbers never ends with, a perfect square number never ends with 2 comma 3 comma 7 comma 8 and odd number of zeros, odd number of zeros. For example, a number ending with 2, for example a number ending with 3, for example a number ends with 7, a number ends with 8, or a number ends with odd number of zeros. For example, you write 2, 5, 3, 6, 0, 0, 0. So here if you observe carefully, it is not at all a perfect square because it is ending with 3 zeros. 3 is an odd number. Therefore, we can decide it is not at all a perfect square. For example, if I write 2, 4, 2, it is not a perfect square number. We can decide because it is ending with 2. So like this is the one of the interesting property. If a number ends with 2 comma 3 comma 7 comma 8 or odd number of zeros, there is no choice. There is no choice. It will never be a perfect square number. This is the second property, and I am going to explain one interesting thing about the perfect square numbers. A perfect square, if A is a number, you say A is any positive number, A is any positive number. If A is divided by 3, you know that according to division algorithm, if a number is divided by 3, there is a choice to get as a remainder 0 comma 1 comma 2. You know that. If A is divided by, a number is divided by 3, there is a choice. You will get sometimes it may be the remainder is 0, sometimes the remainder may be 1, sometimes the remainder may be 2. So here my property is, if a number is divided by 3, if the remainder is 2, if the remainder is 2, if the remainder is equals to 2, it is never a perfect square. It is never a perfect square. This is one of the important property. If a number is divided by 3, if you get the remainder is 2, then it will not be a perfect square number. It does not mean if you get the 0 and 1 as the remainder, they are always not a perfect square. But my explanation is, if you got remainder is 2, then you can decide it is not a perfect square. In the same way, if a number a positive number is divided by 5, if the remainders are 2 and 3, if the remainders are 2 and 3, it is also not a perfect square. So when a number divided by 5, you know that the remainders will be 0 comma 1 comma 2 comma 3 comma 4. If you get the remainders as 2 and 3, so you can decide that number is not a perfect square. If you get the remainders as 0, 1, 4, if you get the remainders as 0, 1, 4, there is a choice, it may be a perfect square. But if you get the remainder as 2 and 3, then you can decide that number is not at all a perfect square. In the same way, when a number a is divided by 7, if a number is divided by 7, if you get the remainder 3 or 5 or 6, so this is also not a perfect square. If a number a divided by 7, if you get the remainders as 3, 5, 6, so you can decide that number also is not a perfect square. So these are some important and interesting properties of a perfect square number. If a number divides by 3, if a number divided by 3, if you get the remainder as 2, then you can decide it is not a perfect square. If a number divided by 5, if you get the remainder 2 and 3, you can decide it is not a perfect square. If a number divided by 7, if you will get the remainders 3, 5, 6, then you can decide this number, that number is not at all a perfect square. So these are one of some interesting properties of a square, perfect square numbers. Then the next concept is how to find the square of a given number. This is very interesting. This is very interesting, how to find a square of a number. There are different types are there. So particularly for 8th and 9th class students, there are two methods in your textbook. So that is, one method is column method is there, and the second method is diagonal method is there. and I will explain you one technique to find the square of two digit numbers also in this method, in this session. So first one is column method. Column method is what? This column method is only useful for two digit numbers. For example, you select any one two digit number. Okay, I will take as 64 square. I want to find the 64 square. So you can multiply 64 into 64. By multiplication also you will get the square of 64. But according to the column method, here you want to make three columns, that is C1, C2 and C3. This is column 1, column 2, column 3. Here you write in column 1 as A square, in column 2 you write 2AB, in column 3 you write B square. So if you know the A plus B whole square, then the terms in the A plus B whole square, those terms are here you required to write in column 1 and column 2 and column 3, A square, 2AB and B square. After writing these three columns, you want to identify what is A and what is B in the given two digit number. The first number you want to take it as A, the second number you want to take it as B. So in 64, A is equal to 6 and B is equal to 4. Now, just you write the values of those, I mean A square. A square means A is equal to 6. Here you write 36. And B square means here you write 16. And 2AB. 2AB means 2 into 6 is 12. 12 fours are 48. So this is the value of 48. So now 64 square is equal, first you take from column 3 your unit digit, that is 6. From column 3 you take the unit digit, that is 6, and you send the tens digit to the column 2 and you add it. If you add these two you will get 49. And afterwards you take the unit digit of this column 2, that is 9, and afterwards you add 4 to this one, you will get 40 here, so 40. So 64 square is equal to 4096. So this is one of the interesting method to find the square of a two digit number. This column method is useful for only two digit numbers. Here just I take an example, that is 64 square. 64 square means this is a two digit number. Here A is equal to 6 and B is equal to 4 I identified. And according to the column method, you want to write three columns, C1, C2, C3. In C1 I wrote as A square, in C2 I wrote as 2AB, in C3 I wrote as B square. And afterwards, according to AB values, you write the values of A square and 2AB and B square. After writing those values, just you take the unit digit number in C3, that is 6. Just I taken 6 from here, and you bring that 1 to C2 and you add it, you will get 49. From that 49 again you take the unit digit, that is 9, and you bring that 4 to the C1, and afterwards you add it, you will get 40. There is no other column, you write the entire number, that is 40. So this is the 64 square value. So this method is called as a column method. By this method you require to find the squares of a two digit numbers. So this is one of the interesting method. Sometimes in exam he will ask you to find the square of two digit numbers by using the column method. Next method is diagonal method. Diagonal method, this is also very useful method to find all types of numbers. It means the first method it is useful for only two digit numbers, but diagonal method it is useful for all types of numbers. I mean two digit numbers, three digit numbers or four digit numbers. So diagonal method means here according to the given number you want to make a square. I mean here I taken one example, that is 123 square. Here this is a 3-digit number. Here this is a 3-digit number. I am finding the square of 123 by using the diagonal method. So here 3 digits are there. Just you draw 3 into 3 square. This is my 3 into 3 square. This is my 3 into 3 square, and afterwards this is 123. Here you write 1, 2, 3. Here also you write 1, 2, 3. 123, 123. So in the method it is mentioned it is as a diagonal. So you want to draw the diagonals. This is one diagonal, and this is diagonal 2, and this is diagonal 3, and this is my diagonal 4, and this is diagonal 5. After drawing the diagonals, just you want to write the values here by multiplying 1 into 1 is 1. Should not write a single digit, you should write 2 digits. This 1 into 1 is 1, therefore 0, 1. 1 into 2, here we are going to multiply this column and this row. 1 into 1 is 0, 1, 1 into 2 is 0, 2, and 1 into 3 is 0, 3. Afterwards you multiply with 2, 2 into 1 is 0, 2, and 2 into 2 is 0, 4, 2 into 3 is 0, 6. After you multiply with 6, this is 3 into 1 is 0, 3, and 3 into 2 is 0, 6, and 3 into 3 is 0, 9. If it is a 2-digit number, you write 2 digits in this box. And afterwards, completion of my columns and completion of my diagonals values, and after multiplication, just you want to find 123 whole square now. So in this diagonal, if you add, what you will get? 9. So if I add these values in this diagonal, this is 6 plus 6 is 12, you write here 2, I mean here 2, you want to write 1 here. And afterwards you add all the values in this diagonal, that is 3 plus 4 is 7, 7 plus 3 is 10, 10 plus 1 is 11, you write 1, and again you take 1 here, and you add all the diagonal values, that is 2 plus 2, 4, 4 plus 1 is 5, and afterwards in this diagonal 1 is there, 0, 1, 0, so this is 1, so there is no value in this diagonal. Therefore 123 square is equal to 15129, so this is the square value of 123. So this is very interesting method to find the big numbers. I mean 4-digit numbers, 5-digit numbers also you can do by this method. Here I taken 3-digit numbers, and if you want to find the 3-digit numbers, means you want to make a 3 into 3 square box, and afterwards you want to draw the diagonals while you are multiplying the values. For example, here 1 into 1 means you don't write 1 here. So if you get the single digit, you want to write 0, 1, 0, 2, 0, 3, and if you get, for example, 23, I mean 7 3s are 21. For example, here 7 is there, here 3 is there. 7 3s are 21 means 2 and 1 you want to write here. For example, here 6 and here also 6 is there. 6 6 are 36. Here you want to write 3 and here you want to write 6. After completion of this box, I mean these values, and you want to add according to the columns, I mean diagonals. This is one diagonal, and afterwards you add this diagonal values, and afterwards you want to add this diagonal values, and this diagonal and this diagonal, you write the answer, that is the 123 square, that is 15,129. So this is very interesting. It will be applicable for all digits, I mean 2 digit, 3 digit, 4 digit numbers. So this is one of the interesting method. This method is called as a diagonal method. If you practice more questions on this method, you feel very easy to find the square of a given number. And another thing I want to tell you, that is how to find the 2-digit numbers. I will tell you one technique. For example, here 37 whole square. I want to write the 37 whole square. So 37, 3 square is equal to 9. One technique I am explaining one technique how to find the 37 square by using a technique. So first you do the square of 3, that is 3 square is equal to 9, you write 0, 9, and afterwards what is the square of 7 is 49, you write 49 here, and afterwards you multiply these 3 numbers in order. 3 7s are 21, 21 2s are 21 2s are is 42. After leaving this first digit, you write 42 here, and you add this one. So this is 9, and this is 6, and this is 13. So 37 square is equal to 1369. You check your answer whether it is right or wrong. For example, if I want to find the value of 46 square, okay, 25 square. First we will do the 25 square. So first you do the square of 2, that is 4. You write 0, 4. And 5 square you write 25, and after you multiply all these numbers in order, 2 5s are 10, 10 2s are 20, you leave the first unit digit and you write here 20, and you add it 5, this is 2, this is 6, so 25 square is equal to 625. So like this also we can find the square of the given number. This rule will be applicable for only 2-digit numbers. So 37 square, first you write the 3 square value, afterwards you write the 7 square value, and you multiply all these numbers in order, and you write that value by leaving the unit digit, and afterwards you add it, and you will get 1369 is the answer. So like that you can find easily the square of 2-digit numbers. Here I given one number, that is 46 square. You practice in this method, you will get easily what is the square of 46. So these 3 methods is enough. to find the square of a number. So another concept is how to find the square root of a given number. How to find the square root of a given number. For example, here I will take one number is 64. 64 is a perfect square number. Now I want to find the square root of 64. Now I want to find the square root of 64. So you know that square root of 64 is 8, but here we require to check our methods how to find the square root of given number. So here I mentioned the first method is successive subtraction. What is successive subtraction? So I will explain you. Successive subtraction will take odd numbers. Odd numbers means 1, 3, 5, 7, 9, 11, these are the odd numbers. So if you subtract these numbers successively, where you will get 0, so that is the square root of 64. I will explain. For example, here given number is 64. First you subtract 0, 1. So if you subtract 1 from the 64, you will get 63. Afterwards you subtract 3. What is the next odd number? Is 3. If you subtract, you will get 60. And afterwards you subtract 5, you will get 55. And afterwards you subtract 7, you become it is 48. And afterwards you subtract 9, this become 39, I think, yes, 39. So afterwards you subtract 11, so it become 8 and 28. And after 11 you subtract 13, this become 15. And afterwards, after 13, what is the odd number? 15, you will get 0. So here I got at last 0. Therefore, how many times? And I mean how many odd numbers I subtracted? If you observe carefully, 1, 2, 3, 4, 5, 6, 7, 8. So 8 odd numbers I subtracted successively. So therefore, root 64 is equal to 8. So this method is called as successive subtraction. By using this method, we can find the square root of 64. But if I want to find the square root of 625, for example, if I want to find the square root of 625, it is so difficult because you want to subtract near about 25 odd numbers. It is very lengthy to find the square root of 625 by this method. But in small numbers, you can find the square root of small numbers by this method. So in this method, just we are subtracting only odd natural numbers, 1, 3, 5, 7, like that we are doing, and where you will get the 0, and afterwards you count how many odd numbers you are subtracted, that is the square root of the given number. This method is given in your textbook, so it is also very interesting. So everybody knows the second method is factorization method. I mean prime factorization. This method is very interesting. If you want to find the square root of 64, same number I am taking. Here I selected one number, this is 225. How to find the square root of 2025? So I am going with the prime factorization method. You know how to do the prime factorization. So this will go by 5 table, 5 4s are 20, 0, 5, again it will go by 5. So 8, 1, and it will go by 3. This is 27, again it will go by 3, this is 9, and 3, 3s are 3, 1s are. Now 2025 is equal to 5 into 5 and 3 into 3 and 3 into 3. Now if I want the square root of 2025, you make pairs, you will get perfect pairs. From each pair you take one factor, that is 5. From this pair you take 3. From this pair you take 3, then it will become 5 into 9, so it becomes 45. Therefore, square root of 2025 is equal to 45. So this method is called as a factorization method. By factorization method also you can find the square root of the given number. Next, so up to now we learn how to find the square root of the given numbers by successive subtraction method and prime factorization method. In these two methods we can find the square root of a perfect square number only, but the last method, it is called as a division method. This is very interesting method. By this division method we can find the square root of a perfect square number. By the way, we can find the square root of non-perfect square numbers also. That values are approximate values. We can find sometimes it may be up to 2 decimal places or 3 decimal places. And by this method we can find perfect square square root, and by the by non-perfect square roots also we can find. For example, in this division method, here I have taken a number that is 271441. So this is my number. Actually it is not a perfect square number. We require to find its square root means in this division method we need to do some pairs from this unit digit to the highest digit. So like this we need to make a pairs, and this is not a normal division. Here we use square numbers only. So 27 is the first pair. If I take 1 1s are 1, 2 2s are 2, 4, 3 3s are 9, 4 4s are 16, 5 5s are 25, 6 6 are 36. So if I write here 6, you want to write here 6. 6 6 are 36, it is greater than 27. Just you take 5 5s are 25. So here you will get 2 if you subtract. And the next step what you want to do means you want to write 5 here and you add these 2. So if you add these 2 you will get 10. 5 plus 5 10, and here remember, when you subtract this you will get 2 here. Next you want to take 2 digits at a time. In common division we will take only 1 digit, but in this finding the square root by division method you want to take a pair. So that is 2 1 4. So if I write here 1, this will begin 101 ones are, and if I write here 2, 102 twos are. So it will be near to 102 twos are. This become 102 twos are 204. So if I subtract this, you will get 10. Again you take 2 here. So this become 104. Next you want to bring down 41. So this will be, if I write here 1, it will become 1. 1041 ones are, 1041 ones are, 1041. So this is also a perfect square. I thought it is not a perfect square, but 521 you got here. So the square root of 27141 so is equal to 521. So like this method we can find the square root of a number in division method. While doing this method, if you practice more, you can learn easily. You want to take only perfect square numbers. Here first you want to make the pairs, and afterwards you have to take the perfect square number you want to apply. So 5 5s are 25, and you subtract it. 2 will be the subtraction. After subtraction you will get here 2, and you want to bring down the 2 digits at a time. And you don't forget to add this 5 to this one. If you add these 2, you will get 10 here. And afterwards what digit here you are writing, the same digit you want to write here. So if I write here 2, then it will become 102 twos are, this is 204. Afterwards it will be 10 will be after subtraction you will get, and you bring down the other 2 digits, and again you want to write 2 here and you add it, that will be 104. And afterwards if you write here 1041 ones are 1041, therefore 521 is the square root of the given number. So these are the methods to find the square roots. So the successive subtraction, it will be useful for the smaller numbers, and the prime factorization, it will be useful for the bigger numbers also, but it is the prime factorization method, it will be useful for only perfect square numbers only. But in division method you can find the square root non-perfect squares also. For example, here I have taken another one number that is in decimal. That is in decimal, my number is 1.5129. You want to find the square root of this one. So it is possible in division method only. So in the same process you want to do, you make pairs here like this and like this. So in the last pair only 1 digit is there, no problem. So 1 1s are 1, 2 2s are 4, 2 2s are 4, it will be bigger. So you take 1 1s are 1, and after subtraction you will get 0. You take 1 here and you add it, it will become 2. Next you take 51 and you are crossing the decimal, you put the decimal here. While bring down 51, you are crossing the decimal, just you put the decimal there. And if I write here 1, 21 ones are 21, 22 twos are 44, 23 threes are, it becomes 69. So it is bigger. So 22 twos are, it will becomes 44. When I subtract it, 51 minus 44, it will become 7. So afterwards, you add 2 here and this will become 24. Next you bring down 29. If I take 3 here, what happened you see? You want to multiply 243, 3s are 3 3s are 9, 3 4s are 12, 3 2s are 6 and 7. So if I write 243 3s are, then it will be 729, the remainder is 0. Therefore, this is the answer. The square root of 1.5129 is equal to 1.23. So this is one of the interesting method. If you practice more, you can find the square root of any big number within some minutes only, you will get this answer. So these are the methods and these are the important things, important points for the squares and square root. So first what we learn about the properties of the perfect square number, and afterwards how to find the square of a number, and in that I explained about two methods. The first method is the column method, second method is the diagonal method, and I explained some technique also how to find the square of a 2-digit number. And afterwards we find the square root of a given number in different method. The first is successive subtraction method, and the second one is the prime factorization method, and third one is the division method. So while completing this class, I am going to tell you an interesting pattern in squares, that is here I wrote how to find the digit 9 squares. So for example, you know that 9 square is equal to 81. So 99 square, it is somewhat complicated, but I will tell you one technique. You make 9, you subtract 1 from the 99 and this become 98, and you make a bar here, and what number I want to add to 9 to make it 9 means it will become 0, and what number I want to add to 8 to make it 9, it will become 1. Therefore 99 square is equal to 9801. So this is the square of this number. If I take 999 whole square, so you subtract 999 minus 1, this become 998, and you make a bar. So what digit I want to add to 9 to make it as a 9 means 0, and what digit I want to add to 9 to make it 9 means 0, and what digit I want to add, so that is 1. So 999 whole square, 999 whole square is equal to 998001. This is the answer. So it will be applicable, this pattern will be applicable for 9 digit squares. 9 square you can write as a 81, and 99, just you subtract 1 from the 99, that is 98, and afterwards you want to write again 2 digits. 9 plus 0 is 9, so you want to write here 0. 8 plus 1 is 9, so you want to write here 1. So the answer of 99 square is 9801. This will be applicable for 9999. For example, if I take 4 9s whole square, so you subtract 1 from this will be 9998, and you keep a bar, so 0001. So this is 99980001. This is the square of 9999. So this rule is applicable for 9-digit numbers only. So there are some patterns, there are some different techniques also is there, and I will explain those techniques in later. But the concept of square and square roots are very interesting, and you learn these concepts perfectly. It will be useful for your future classes also. Thank you.